Alright, these are just examples of the conic sections written in expanded form. And you should be able to recognize what type of graph each one of them is without really finding a lot of information. For instance, this one has a y squared, a y, an x, and a constant. Well, the highest power of x is 1, and there's a y squared involved, so this one is more than likely a parabola, because there's only one squared term and a linear second term. Alright, so let's look at my next example. This one here has an x squared and a y squared and a smattering of x's and y's and a constant. But because it's an x squared plus a y squared, this thing is going to be an ellipse. And lastly, we have this one, which has an x squared and a y squared also, but the y squared is positive and the x squared is negative. So when they're not exactly the same sign, then this is going to be, or opposite signs I should say, for the square terms, this one's going to be the hyperbola. Alright, now let's go back and find the translation of this and how to graph it. Alright, so we're going to be using a lot of completing the square because you can't have a y squared and a y in a parabola, ellipse, or a hyperbola. It's usually y squared by itself or a y minus something all squared. So we're going to complete the square on just the y's, and I'm going to move the 8x and the 20 to the other side. So to complete the square, my technique is to group the y's, leave a little space for some work, and push everything else to the other side. Now that's going to work fine here, but the other two I'm going to have to do it a little bit different. Alright, so to complete the square, the technique is to go for the middle coefficient, -4, cut it in half. So half of it is going to be -2. The sign becomes important, and this number does also in the next step. You're going to square it. And when you square it, you're going to add 4 to this side. Well, you just added 4 to the left-hand side, so that means you also have to add 4 to the right-hand side to balance the equation out. Now this technique always generates a perfect square out of this trinomial, and it's going to be based on this number -2. So this becomes y minus 2 all squared is equal to 8x plus 24. Alright, now this other side is also kind of a little strange. Usually on the other side of a parabola you have the 4a term in front and then the x-ish term in the back end. So here we're also going to have to do a little bit of factoring. So this is going to become y minus 2 squared is equal to, and I can pull out an 8. And actually you're going to have to pull out whatever number is sitting in front of this x. So if I kick out the 8, left behind is x plus 3. So that's the general setup of a translated parabola. And I know a little bit about the information from here. The vertex of this is going to be -3 for the x-coordinate, +2 for the y-coordinate, and I also know that 4a is equal to 8. Therefore, a is equal to 2. And I can graph this thing. So let's put our information into the graph. First off, let's do the imaginary stuff first. The vertex is going to be a physical point on the graph, -3, 2. So -3, 2. The imaginary axes are going to be going through this point. So we're going to have one here going across at -2. I'm not drawing it very prettily. And then another one going through that point vertically at x equals -3. I'll draw my point over again. Alright, so this is going to be the vertex of my parabola. Now because it's y squared, it's going to be facing left or right. Because the a is positive, this thing is definitely going to the right. So when we draw in our focus, it's 2 units to the right. So you start at the vertex and you go 1, 2, and there's our focus. We'll label it F. Oop, we'll go back and label this V because that's our vertex. If you want, the directrix is the opposite direction. I'll put it in green. So if you go from the vertex to the focus to the right, you go from the vertex to the focus to the left 2 units, and it becomes a vertical line on the back side of this parabola. So this is the directrix. Again, it's only necessary for this if you're going to do it by definition. You know, the focus, a line from a point to the focus is the same distance as the, the line segment from the vertex to the focus has the same distance as the vertex to the directrix, and any point of the parabola. All right, the second part of the graph that we're going to put is the points above and below the focus along the lattice rectum. All right, and that distance has to be 2a up and 2a down for a total distance of 8. Remember, the lattice rectum is this number in front, or the absolute value of it, lengthwise. So we're going to go 4 up and 4 down from this point to come up with the other 2 points. 1, 2, 3, 4 up, someplace up here. Now the coordinate of this point, this started at 2, so this would be 3, 4, 5, 6. So this would have a coordinate of -1, 6. And then if we went down 4, 1, 2, 3, 4, we'd have this one down here at a coordinate of -1, -2. And then we can draw our parabola through the lattice rectum points and the vertex. We get something that looks like that. All right, and that's all the information we can rip out of this equation to graph it. All right, the next one up is our ellipse, and we're going to basically do the exact same thing. We're going to group the x's, we're going to group the y's, and this one I'm going to leave these two on the same side, and the only thing I can kick over is the 4. While I'm grouping the x's, we need a lead coefficient of 1, otherwise completing the square doesn't work. So as I group them, I'm going to kick out that 4, leaving behind x squared minus 2x. And then I'm going to leave a space. And this is where it's going to get a little tricky compared to the parabola one. The same thing here. As I group them, I'm also going to kick out that lead coefficient of 5 and leave behind y squared plus 4y and leave a space. And then the only thing left over is that plus 4, and I'm going to kick it to the other side so it becomes minus 4. Now when I perform the completing the square, it's kind of going to work the same for the inside stuff, but the number that I'm going to put on the other side is not very clear until we look at it in detail. So we're going to take half of -2, -1. We're going to square it, which would be plus 1. But when I put this plus 1 here, I'm not really adding 1 to the left-hand side of this equation, because sitting out here is this 4, and it's going to distribute and hit that 1. So what I've really added by placing that 1 here is 4. So because of this adding 4, over here we're also going to have to add 4. Alright, same thing for the 4y. We're going to take half of its coefficient, which is positive 2. We're going to square it. It's going to give us positive 4. But in reality, we didn't add 4 here. We added 20. So on this side, we're going to have to add 20. Alright, so let's write our perfect squares. This is going to be 4 times the quantity. The important number is the -1, so it becomes x minus 1 all squared, plus 5 times the quantity, oops, and this is the important number, so we're going to get y, because it is the y variable, plus 2 all squared, and on the other side is 20. Now, a proper ellipse has those nice fractions and generally lead coefficients of 1 here, if we want to find directly what a and b are. So I'm going to divide everything by 20. So the first one's going to become x minus 1 squared over 5 plus y plus 2 all squared all over 4, and this will equal 1. Okay. So the center of this picture is going to be located at 1, negative 2. 1 from here, negative 2 from there. Since it's an ellipse, the a has to be the bigger number. So in this case, a squared is equal to 5. And that leaves b squared to equal 4. Center. I better just write center here because c is something else. So the formula for the ellipse is c squared is equal to a squared minus b squared. Thus, the a has to be bigger. So c is going to equal, let's see here, 1, plus or minus 1. And then a is going to equal the square root of 5, and b is going to equal 2. All right, so let's take all this information that we have here and graph our ellipse. Let's start off with the center. The center here is 1, negative 2. So 1, negative 2. Again, we're going to have our imaginary axes going through this point. I like drawing these in for reference purposes and also to keep my focus on those two lines because that's where most of the ellipse is going to go. Alright, we can plot our vertices. The square root of 5 is just a little bit bigger than 2. You know, square root of 4 is 2, so square root of 5 is a little bit bigger. And then b here is directly 2, and then c is just 1. So let's see here. A. Now a is underneath the x term, so the major axis is going to go along the horizontal, and b is underneath the y term, so the b part is the minor axis is going to go vertical. Alright, so we need to go square root of 5 from this point to the right and left, so it's a little bit bigger than 2, and it's a little bit bigger than negative 2. So this will be our major axis between those 2 points. B is directly 2, so that's going to be kind of easy. From the center up 2, and from the center down 2. And if we want to put our foci in, it's going to be 1 to the right. We'll call that foci 1, and 1 to the left. Call that foci 2. Focus 2 of the foci. Alright, and then we can draw our ellipse. Not bad. And there we have it. So this would be the graph of this ellipse. Alright, the last one, the hyperbola. Is going to be done exactly the same as the ellipse, though I'm going to rearrange this a little bit more than I did with the ellipse, especially because this one is being negative and this one is the positive term. Alright, so I'm going to rearrange this. So the y's I'm going to put first. So y squared minus 4y. And since the y squared term has lead coefficient of 1, I don't have to worry about factoring anything out. Leave a space. When I get to the x terms, the lead coefficient is negative 4, so I'm going to kick that out first. So after I kick out the negative 4, factor it out, you're left behind with x squared plus 6x. So this will be x squared plus 6x. And then leave a space. And that leaves that 40. So I'm going to move the negative 40 over to become positive 40. Alright, and then complete the square. So half of the coefficient of the y term here is negative 2. Square it, we're going to get positive 4. There's nothing funny happening to it. There's no multiplying factor out here. So I'm just going to add 4 to the other side. Here, the coefficient of x is 6, so I'm going to take half of that, which is positive 3. Square it, that's positive 9. But in this case, I do have a multiplying factor of negative 4. So negative 4 times negative 9 is negative 36. So over here I'm going to have to subtract 36. All right. So this becomes y minus 2 all squared, because that's the important number, minus 4 times x plus 3. Make sure you get your variables straight when you're doing this. It's real easy to put the y there and the x there. And this will equal, let's see here, 40 plus 4 is 44, minus 36, that's 8. All right. So with a hyperbola also, you want to get this side equal to 1, so I'm going to divide everybody by 8. We're going to end up with y minus 2 all squared all over 8 minus x plus 3 all squared all over 2. And this is equal to 1. All right, so the center is going to be at, x coordinate will be negative 3, y coordinate will be positive 2. A, in this case, is related to the y. For hyperbolas, it's the first number, the positive first number. So a squared is going to be 8. And that leaves b squared to being the other number, which is 2. And c squared is equal to the sum of those two numbers, a squared plus b squared. So this will be 10, and therefore a is equal to 2 square roots of 2. B is equal to the square root of 2, and C is equal to the square root of 10. All right. These I'm going to have to come up with decimal approximations. So 2 square roots of 2, that's 2.8. Square root of 2, if I remember right, is like 1.4. 1.4. And square root of 10 is a little bit bigger than 3 because it's close to the square root of 9, 3.2. And I only need those so I can graph this nicely. All right, so next up, let's graph it. Let's start with the center. So negative 3, 2 is the center. So we're going to go negative 3, 2 is here. So the imaginary axes go through this. We get that. The only points that are going to happen on this happen under the first term. So we're talking about y, which is going up and down, and the 8, which is related to this a equals 2.8. So from here, we're going to go 2.8 up, and this becomes one of the vertices of the hyperbola. And we're going to go 2.8 down, and that becomes the other vertice of this hyperbola. Now this whole graph is going to be approximations because of all the decimals involved. All right, the other numbers are not used specifically for the graph, but they're used for the box. So the b, the 1.4, is going to go 1.4 to the left and right of here. So I'm just going to mark them a little bit lightly. And then we're going to do the box that contains these. So I'm going to draw a horizontal line here, a vertical line through the B point, horizontal line through the A point, and a vertical line through the B point. And then draw in my asymptotes, or try to. I'll use the computer to do it. Wrong color. Go with green. So we'll start here and draw a line through that corner. Start here, draw a line through that corner. And then go backwards. I'm going to put this thing up into the words here. All right, so now I can draw my hyperbola. I didn't put my focuses in yet. I'll put those in last. So the hyperbola is going to start here at the vertex, and it's going to come across. Let me do it thick. And follow the asymptote. and then it's going to come the other way and follow the asymptote. And the same thing on the bottom. It starts at the vertex and goes down, and oops, this one also goes down. Technically they don't touch. I'm having a hard time keeping my marker away from that green line. Alright, so let's put in the foci. So the foci are 3.2 away, so this would be 1, 2, 3.2, right about here. Now I can write the specific coordinate of that point. That's not too bad. This, go back to thin, is going to be along the line x equals -3. So the first coordinate is -3. The second coordinate is, you start with the vertex y coordinate, which was 2. So it's going to start off with 2. And since we went down, the c value, so that would be -3, 2 minus square root of 10. The other one's up here someplace, 1.4 above, 3.2, so 1, 2, that was about 3.2 would be right about here. And this foci would have a coordinate of going up and down, doesn't change anything. We started at 2 and we added square root of 10. And that would be foci 2, and this one is foci 1. Alright, so that would be the complete graph of a hyperbola.